Welcome to the CCOM-OE Seminar. Today, we're lucky to have Professor Deborah Greaves with us. Deborah Greaves is head of the School of Engineering, Computing, and Mathematics, professor of ocean engineering, and director of the Coast Laboratory at the University of Plymouth, with previous appointments at Oxford, UCL, and the University of Bath. Her research interests include marine and offshore renewable energy and physical and numerical modeling of wave structure interaction. She has led many national and international research projects concerning offshore renewable energy in collaboration with industrial and academic partners, and is director of the EPSRC €9 million Supergen Offshore Renewable Energy Hub. In the Queen's Birthday Honors List 2018, she was awarded an OBE for services to marine renewable energy, equalities, and higher education. And in 2020, she was elected to be a Fellow of the Royal Academy of Engineering. Deborah Greaves, you can share your screen now and present.
Okay, good. I hope you can see that all right. Please shout if you can't. But yes, thank you very much indeed for the invitation today. It's very nice to speak to you. And thank you for the introduction. So what I'd like to do today is talk to you a little bit about this project, this Supergen Offshore Renewable Energy Hub that I'm running, and tell you about that and about the research that we're doing within it, and then take any questions. So Supergen is a program of research that's funded by the EPSRC, and that's our Engineering and Physical Sciences Research Council in the UK. Now, we're all aware of the climate emergency that we're under at the moment, and in the UK we have ambitions for net zero greenhouse gas emissions by 2050. And the offshore renewable energy sector and the technologies within offshore renewable energy we see as a major contributors to this. The Supergen is all about sustainable energy generation, and it's part of that supply side for achieving net zero. So the hub program, the idea of this is a large program of research, and it's to provide this research leadership for the sector of offshore renewable energy. And what we try to do is to connect together the academics with industry and policymakers and publics as well, so that we can raise the understanding and awareness of offshore renewable energy and its role, and connect people together and inspire innovation and research to maximise the societal value in offshore wind, wave and tidal energy. So the objectives of the hub are to do that research leadership part, connecting and inspiring people to carry out research and inspire others to do research. We have funding to do a core programme of research within the consortium. And then also we have, of our 9 million budget over 4 years, we've got about £3 million of that we're able to allocate out in flexible funding calls. So we're actually facilitating calls for proposals and funding other groups around the UK to do that research. We also have an eye on the future, and in particular looking at the sustainability of our area. And so we have a focus on developing early career researchers and building up the early career researcher networks. And we also have an aim to become a beacon for equality, diversity and inclusion. And this is added here, or this is a important part of our objectives or our aim, because it's recognised that there's a real lack of diversity in engineering, but also in particular in energy. So that's a really important one. So then we want to, by connecting these different groups together, we want to be a respected voice for policymakers and trusted partner for industry. But also we do a lot of work working with international groups and strengthen our international collaboration. And then very importantly, try to take a whole systems approach to offshore renewable energy. So we're not just focusing on the technology solution, but also thinking about how it's going to interact with the environment and how it's going to be adopted by the people that need to use it. So offshore renewable energy is included within that is offshore wind, wave energy and tidal stream energy. Those are the three main technology areas that we count within offshore renewable energy. Those are our areas of focus. And it's interesting to bring them together because they were previously by the EPSRC treated separately. So we had marine energy to include wave energy and tidal stream, and then wind would include onshore and offshore wind. But now in this new program of work, we're bringing these offshore wind, wave and tidal together because of the synergies between them, because they all need to operate in the marine environment, of course, interact with the marine environment and the environmental conditions that they would experience there. But also, if we think about the stage of development of these different technologies, offshore wind in the UK is very well established now, and we've seen enormous price reductions in the cost of energy as well. But the new frontier, in order to generate a sufficient needed for net zero, we need to go further offshore and into deeper water, and that means that we need to look at floating offshore wind solutions in order to achieve the goals of net zero. So for offshore wind, the challenge is really to move to floating offshore wind and to generate the innovation needed for those. In wave and tidal energy, and we're really looking at tidal stream energy, then in those areas they're at a much earlier stage. They're not commercialized yet, they're still at the demonstration or research stages, and really need to achieve significant cost reductions to become more commercial. But as I say, there's synergies between each of them, and good research can be shared between all three technologies. So this is a map of the UK, and it shows you where the different members of the consortium are based. So this is me down here in Plymouth, and then we have other co-directors of the hub scattered around the UK, up into Aberdeen and in all other parts of the UK. So we've got 9 co-directors, 10 universities in all working together, all with contributions in different disciplines and different sectors, and there we all are. And then we also have an industry advisory board, so it's really important that the research we're doing in offshore renewable energy will find its way into practice. And so it's important for us to work closely with industry and with organisations like BEIS, which is the funding or central government funding for research and innovation, and then things like the Catapult, which is a setup to bring industry innovation together with academia. And then the others, of course, are all companies involved in offshore renewable energy in one way or another. And what we do within our research leadership, I mentioned before, we want to inspire research, and we want to connect people together that can work together in that research. And in order to sort of join these two areas together, so on this side we've got, if you like, all of the research that's going on in the UK in offshore renewable energy, and some of that is funded directly by the hub, some of this is the flexible fund, some is the core research, and then there's lots of other research that's going on related to offshore renewable energy. We want to be able to put that through a lens and then sort of promote it out to the end users, if you like, and to government and to industry and policymakers and so on. And we try to do that through our research landscape, which is a web tool. I'm not going to be able to demonstrate it to you with its full capability because I don't think the internet connection can cope with a movie very well. But if you want to have a look at our website, you can come to the website and click on here, and that will take you through to the research landscape. So I've just taken a few stills of it here so you can have a look. But within this research landscape web tool, we've tried to summarize lots of information about the area of offshore renewable energy and the research challenges within it. So I've got a nice sort of infographic here showing different types of offshore renewable energy. So we've got fixed offshore wind structures, a couple of floating offshore wind turbines here, and then there's a farm in the background. We've got some tidal stream devices on the seabed down here, and then 2 different types of wave energy device also there. And then on the left-hand side, we have a list of themes. So we've got these research themes, and within each theme, there are a number of research challenges. And these research challenges and themes have been put together through a series of consultation, workshops and exercises working with academics and industry and others. So if we explore this a little bit further, if we click into one of those themes, then you'll find these buttons appear around the landscape in relevant positions. And then if we click on one of those, then we get a bit more information. Here we've got information about the research challenge itself, the overview, and then we can go find out more about its context, and then the status. And then if you click on this button to delve deeper, you can click on that to delve deeper, and that will take you further into the website, where you'll get some links through to projects and research papers and so on related to the research challenge. And also it's a sort of community tool, so we've also got a place there to add in projects so people can put their own projects in and have them promoted. So that's our research landscape, and do please have a look around that. But that really enables us to set the context for the whole of the research hub. And then within that research landscape, we've designed our core research program, and then we also target our flexible funding calls also using that research landscape. So I just want to say a little bit about the core research program, and then I will later on I'll say a little bit more about the bit that I've been doing, particularly involved with. But we have 5 different work packages within our research program. And the first one is about what we're calling demonstration of scenarios. And this research program is really designed around bringing together offshore wind with wave and tidal, and recognizing that each of those are at quite different stages of development, of commercialization, if you like, but they have some common synergies, and they have some common research challenges. They also have specific ones. But in each case, in order to accelerate and to advance their development and progression, then there are sort of technological step changes that needed to be made. So there are some research challenges or innovation technical challenges that need to be overcome in order for them to advance and to move forward. So this first work package is looking at those scenarios that we would aim for within the next 20-30 years, and we've called these aspirational ORE systems. So for floating offshore wind, then we might be looking at the next generation of floating offshore wind turbines, and then deployed in a large floating offshore wind farm. Whereas for wave energy, we might be looking at new technology, disruptive technology, which would allow significant cost reduction, and survivability to be sort of demonstrated and proven. Okay, so this first work package is really setting the scene and thinking about what are those scenarios, what are those different deployments that we might be looking at, and then thinking about the technology innovations that would be needed in order to get there. And in setting out these deployments, we're using energy systems modelling. This helps us to also assess the economic benefits, the GVA, gross value added. So that's in terms of economic benefit and number of jobs created. And then also, not just focusing on the economics, we're also bringing into this the ecological assessment. So trying to understand the ecological impact or benefit of these different scenarios as well. So that sets the scene. And then in work package 2, we want to look at the sites and conditions and create data sets and test beds that can be used as benchmark sets and by others for assessments. So we're looking at different sites where there are data available about those sites. So for example, we have some wave energy demonstration and tidal stream demonstration sites, and also some offshore wind demonstration sites in the UK. And in some cases, the data is freely available. We've also got, obviously, there are also some commercial projects where the data might be more sensitive. But what we want to do is to try and put together those data sets so that they can be made available to others for research as well. And also we, you know, where that open data is not available, then we can also develop synthetic data for sites. So this is data for studies in offshore wind and wave and tidal energy. And we're looking at putting together metocean data, so wind and wave data, and we have data from various different sites around the UK. So Fab Test is in Falmouth Bay test site for sort of nursery scale testing of wave energy devices. And then EMEC is the European Marine Energy Centre, where a number of wave energy devices and also tidal stream devices have been tested over a number of years. And that data will all be freely available, but it also includes not just that sort of data about the waves and the wind and the currents and so on, but also things like the seabed condition, and also where possible the ecological information as well, the marine ecosystem data. So this is a movie running along the cable line at EMEC for one of the deployments, the Maygen deployments. Maygen is a demonstration project for tidal stream at EMEC. Okay, and then the third work package is about modelling, developing our numerical models and building greater confidence in those, particularly looking at tidal stream and arrays, but also looking at offshore wind and turbine wind interactions as well. So this numerical modelling work is looking at how we can improve the regional scale array effects and how we can bring the right information from one scale to another when we move from very local models through to regional and then larger scale models. But in this, so particularly with tidal stream farms, then we need to understand the impact of the presence of the farm on the resource itself and how that interaction works in both directions, from the performance of the farm and also the resource. And then also the interaction with marine populations as well. So we're integrating a lot of this modelling work with ecological modelling as well, to look at the impact on marine populations. And we can use this data for performance modelling or assessment, but also for assessment of fatigue loading and lifetime of and design of blades and of turbines and so on. Then looking at the feedback between different scales and also operational arrays to regional scale, looking at the wake interaction effects and seeing how that can be modelled better, and where also running a series of experiments, benchmark experiments for tidal turbines, which will be hopefully showcased at the European Wave and Tidal Energy Conference, which is coming up in September this year. Okay, and then work package 4 is all about design, looking at how we can essentially make our designs less conservative. We can reduce cost and risk by design, by having more confidence or less uncertainty or better understanding of the uncertainties in the parameters that go into design. And this includes the environmental conditions, but also the structures themselves and the components of those. So we have a number of experiments and techniques being developed to look at how we can improve design, and I'll talk about that a little bit more if we've got time later on. And then the fifth work package, final work package, is all about floating futures, and this is the work package that sort of brings everything together and is all really thinking about what are the future designs and innovations, and how do we realise some of those aspirational offshore renewable energy systems, those futuristic systems that we need to get to by 2050, or we might see develop over the next 20, 30 years. So here we're looking at what are the new innovations needed in offshore wind. We're very familiar with the fixed offshore wind turbine, monopile structure, and three-bladed horizontal axis turbine. But is that the right solution when we are no longer constrained by being close to the shore, and maybe not even constrained with a grid connection? So if we look further offshore to floating structures, does that sort of enable some very different design innovations and some disruptive technologies to come forward? And here, this slide shows the different approaches to achieving stability and the different approaches to floating offshore wind structured development. So you can see the range of those from spar type devices, and there's sway spar, and then to semi-sub type devices, often catenary moored, and then we also see some which are tension leg moored to the platform. So different approaches to stabilizing the mooring, different approaches to stabilizing the buoyancy, and also the ballast. Okay. And then, of course, there are also opportunities for having multiple turbines on a single platform. So looking at very large platforms, and here's an example of a floating runway, but that same sort of idea can be applied to a floating offshore renewable energy farm, perhaps which combines solar with wind as well. What are the limitations for this kind of development, and for multiple rotors and so on? So we want to look at the limits for design of this type of futuristic offshore wind installation, but also looking at the limitations on the environment as well, so the carrying capacity of the marine space, and making sure that we are optimizing that and not damaging it. Okay, so that sort of gives you a brief run through of the scope of the core research programme. And as I said before, these are the people involved with it. And if you want to find out more about the core research programme, you can look on our website, and there's lots of information there. Then we have flexible funding, which is commissioned research that we put out through a series of calls. And I've just added the dots there of the locations where that flexible funding is being carried out. And also we have an early career researcher community, and we have some specific funding targeted at early career researchers. And so that's distributed like that. And again, there's a link there for each of those different areas that you can follow and find out more about it. For the flexible funding, we've got 3 rounds of flexible funding that we've run. We're in the middle of the 3rd round at the moment. A total of £3 million going into this flexible funding. And the first 2 rounds, we funded 22 projects. And as I mentioned earlier on, we're really keen for the research that we're funding to make its way into practice. And so we're keen to see that pathway to impact generated by working closely with industry to make sure that the research challenges we're addressing are relevant to them, and also can be implemented within a reasonable timescale. So it's really good to see this level of industry match. So this is industry contribution or participation in the research, valued at 2.4 million. So as I mentioned, we're in the middle of round 3, and that's being assessed soon. We're very pleased actually in round 2 and round 3 to have been able to sort of increase the amount of funding we could give by working closely with the Offshore Renewable Energy Catapult, and also a new floating offshore wind centre of excellence that they're running, which has put some funds into our flexible funding as well, so that's great. Now, one of the things we're trying to do is to address ED&I, so equality, diversity and inclusion. We want to make sure we can achieve better diversity in this sector. And so one way to try and do that is to try to remove unconscious bias from the reviewing process when we're assessing proposals and allocating funding for proposals. So what we've introduced is a 2-stage blind review process, which means when the research proposals are submitted, then we don't have they're fully anonymised, so we don't know who the research team is going to be. We assess the research proposal based on its quality of the idea, and then it's a second stage. We look at the research teams and make sure they have the right sort of resource and capability. But in that way, it enables us to have achieved a much better diversity already, I think, in the funding that we've been able to allocate, which is great. And we've also been working across with other hubs and other disciplines. So we're putting some of our CCOM funding into work with other supergens, looking at networks and storage. So we had a focused bit of CCOM funding in that, and also just recently we've run a CCOM workshop with the robotics hub as well, to look at sort of sparking some research focused on the challenge of developing robotics for offshore renewable energy. Our early career researcher, or ECR network, is very active and has a number of workshops and outreach events alongside what we do within our annual assemblies, and we also run training and funding calls for them. We've done various sort of policy activities. For example, we were commissioned to develop a wave energy roadmap. One of the one aspect of wave energy is that it has been sort of funded in a quite a lumpy way over the last 20 years. It's secured, it's had quite a bit of support, and then that support has sort of waxed and waned a little bit. And so we were asked to sort of do some work to think about what is really needed to kickstart wave energy and to get things moving again. So we developed we did some workshops and some work with the community, and we developed a wave energy innovation position paper and also a roadmap of actions and sort of focus needed to really realise the potential of wave energy, and that's led into a sort of targeted funding call from UPSRC into wave energy. So you can find out more about that also on the website and find the report there. We've also developed a report on ED&I. So this is a scoping study to start with, really looking at the issue, trying to understand the issue of EDI within energy. And this work was funded by the Supergen and also by another consortium called Aura, and working with the sector deal for offshore wind. And it very recently launched, and lots of good ideas in there about how you can take actions at different stages in the career to try to prevent the leakage of well, it's particularly girls and women in their careers to get them to sort of stay in STEM subjects and to stay in engineering. So there's some good suggestions in there. We've also have an area of our site where we have an interactive map which has links through to the facilities available for research and innovation in offshore renewable energy. And we do a lot of outreach and engagement work. Some of the things that we have done recently, we've run an outreach hands-on sort of activity as part of a festival. We had a Houses of Parliament launch event and some other activities that we've actually just launched a competition for to develop a mobile game about offshore renewable energy. We're developing a children's book and teaching materials, so we're really trying to target different age groups and to get people more familiar with the potential for offshore renewable energy, to understand it better. And then we also run a series of events. These won't be of so much interest, but I think some of you might be interested in UTEC, which is the European Wave and Tidal Energy Conference, and that's running in September this year, and it's hosted by the University of Plymouth, so it'd be great to have some of you here. It'll be partly online, of course. Okay, I think I've got a little bit of time when I can now, so I can just tell you a little bit more detail about some of our design work that we've been doing towards Work Package 4. This is what we've been doing at the University of Plymouth. And what we're trying to do, as I said before, is to use design, or to use the design process in order to find ways to reduce costs by understanding more about the uncertainties around design for offshore renewable energy structures. And what we find is that the design practices that we have for offshore renewable energy are mostly inherited from the oil and gas sector and from coastal engineering. And often these are fairly static structures, or even fully static structures. And so the difference between those and, of course, offshore renewable energy floating structures is that they are more dynamic, and so this means that the design challenge is quite different. So whereas for a fixed structure you might be interested in trying to work out what the largest wave height of the wave that's going to hit it's going to be, when you're talking about a floating structure that's moored to the seabed, then it's the history of its motion before the wave hits, as well as the particular phase of that wave. So it's a much more complicated issue. So what we want to do is have a look at whether we can develop probabilistic design assessment methods for floating offshore renewable energy structures, and look at how that can help us to have a better understanding of the uncertainties in the problem, and therefore be able to perhaps achieve more optimal reliability levels in order to reduce the costs. And to do this, we will then be making recommendations for design standards in how these methodologies can be used. We'll be combining together numerical models and experiments in the wave tank. But to start this, we need to think about where the device, or where the machine is going to be located. So we need to base our design on the data which is taken from the site that we're designing our device to be located. And what we've done is we've looked at data which is openly available for the EMEC site, and also for WaveHub, which is a site in the southwest of the UK, off the north coast of Cornwall, and it was set up for at-sea demonstration of wave energy, and there's a lot of data available there. So we can take that data over a long time period, so this is about 30 years of data, and then we can use that to do some extreme value analysis to work out what the contours are of the different return period wave combinations. So that's what this chart shows here for data at the EMEC site. And in order to design tests to generate the critical load cases, or to understand what the critical loads might be for a device, then we can either run long duration irregular waves and pick out what the extremes are, what the extreme loads are and the extreme responses, or we can try to design short waves which will reproduce those extreme critical or those critical load cases. So this has been done for a while, and in offshore engineering then some of you might be familiar with the concept of new wave, which is a design wave, short design wave, which represents the most likely extreme wave in a given sea state. And the advantage of a short design wave is that it's much quicker to run, so you can do lots of them in the wave tank or in your numerical experiment. And also that it's possible to use things like computational fluid dynamics for a short wave. But as I said before, if the device itself is moving around, then using new wave, which is the average largest wave, may not be the best solution. So instead, you can use a similar idea, but based on the responses of your structure. So we're also looking at these short design waves based on the response of the structure. These investigations are being done for wave energy and also for floating offshore wind. We're not looking at tidal stream in this case, although for a floating tidal stream setup, then that would be relevant. For the wave energy cases, we've done lots of work on this, which is we call it the XMED buoy, but it's a very simple buoy taut moored to the seabed with a linear spring. Doesn't have a power takeoff representation, so it's quite a simple thing. We're also looking at a more complicated floating structure. This is a hinged raft, and this is a more simple hinged raft. This yellow one at the top is the Motion device. We're working with a company called Motion, who are developing this. It's called Blue Star, actually, and it's a very optimized wave energy converter. The idea is that it's a hinged raft, so the power takeoff will be in the hinge here, and these two sections will move in the sea, in the waves, relative to one another, and we can take off, put a generator in the power takeoff in the hinge. And then for the floating offshore wind case, then we're planning to use this sort of standard turbine, which is a 15 megawatt turbine with the Vulture US floating wind platform, which was developed at the University of Maine. And this just shows an example of some of the experiments we've done using new wave, which is this average extreme wave in a series, and we can embed that, constrain it into a random sea state, and then these show some experiment data in blue and some WEXIM numerical model simulations of the experiments, and those are in orange, and you can see they're pretty similar. They're not bad. The heave is pretty good, surge position, some differences, and the spring extension, that's going to be very similar to the heave position. But in all cases, you can see that the extreme heave, the extreme spring extension as well, has been captured in the experiment and in the numerical model. The hinged raft is a little bit more complicated, of course, because it's got two bodies and it's got a hinge, so it's not quite as simple as the other device. This is a picture of it in the wave tank. These strange sort of sticks with the blobs on the top, that's part of our 6-degree of freedom motion measurement system, and these are reflectors which are picked, and their motion, their movement is picked up by some infrared cameras, and that gives us a 6-degree of freedom motion to a great accuracy. This shows some of the results for that case in regular waves, small regular waves. And really, that slide just shows how the responses are all quite linear. Let me just see if this is going to work. Is it okay, or is it looking very choppy? I won't play it for long anyway. It's okay, is it? So this is our coast laboratory at the University of Plymouth, and this is our large wave tank, the ocean basin. And here's the hinge draft device with those little balls on the top in the lab in the experiment there. So we ran a series of experiments for random sea states, and also tested out this idea of design short waves using short waves which were the average wave profile that would lead to the maximum extreme response, but under fairly linear conditions. And what you can see here are 30 different realizations of that. So this is the black line is the average wave profile, and we've embedded that within a short random sea state, and so those are the variations at each end. And then on the right hand side, this is the mooring load we get out of each of those cases. So it's pretty well conditioned here, and you can see that the mooring load is varying around a mean quite nicely, as we would hope for this case. However, if we move into more non-linear situation, so we increase the load regime, so this is 1.5 to 2 newtons, and then we're sort of increasing as we go. In this case, the wave profile is similar to that predicted from the response amplitude operators of the device. But as we increase the load, the shape of that changes quite a bit, and it becomes much more similar here for the very high load cases to the new wave. And new wave shape is like this with a single large peak and then some roughly symmetric troughs on either side. And this is what we see for the high load cases, and in this case we have snatch load happening. So for the very high critical load cases, the shape of or the profile of the wave that creates it is more like this, which is more like a new wave, but the mooring load that you get out from applying this in the wave tank is much more variable. And you can see here we no longer have that nicely conditioned response with the mean surrounded by some well-conditioned variability. Here it's really very hard to predict that load, and this is due to the non-linearities of the snatch. We also have numerical modelling that we can use in order to try to reproduce these cases where we've got things like snatch loading occurring. There's a lot of non-linearities going on there, and that means that our WEXIM, our linear model, is probably not going to pick it up very well. So we need to use more sophisticated numerical modelling like computational fluid dynamics. And this slide shows some results of a simplified hinge draft simulated using WEXIM on the bottom, that's the linearized approach, and fully nonlinear computational fluid dynamics on the top. And we'd expect the CFD results to be a little bit different and to pick up more of the non-linearities. Okay, and then this is another movie which is, I'll just play a little bit of, and that's the more simplified device in the lab. Also the hinge draft. So what we've shown is that, well, sort of partway through this work, really, we've shown that the embedded focus waves can be used to reproduce those extreme responses well, even for floating devices, but generally for the more linearized cases. Where we have things like snatch load occurring, then it's a challenge for those techniques to pick it up because they're based on linear RAOs. So we want to extend this research. We've got some more experiments to do for the simplified hinge draft case. The motion device is quite complicated with the moon pool and so on. And so we want to look at it as a more simplified case. And then also we're going to test the floating offshore wind turbine as well and apply these cases to that. Okay, and I just want to finish by pointing you to this resource as well. We've recently had our annual assembly for the Supergen, where we have a sort of conference with lots of discussion the research and various other aspects, policy and EDI and all sorts of other international collaborations and all sorts of things. That information is all available, videos and so on, recordings through our website. So if you're interested in finding out more, then please do go and have a look, and you can view the content online. And please stay in touch, and thank you very much indeed. That's me. Have you got any questions?
Thank you so much for your presentation. It was very interesting, and we really appreciate the time that you spent to put it together and give us some information on what's going on with Supergen. I already saw that we have some questions, but if anyone else would like to ask any, feel free to type it into the chat and we will read it aloud, or you can unmute yourself and ask directly. So I will start with the questions that I see in the chat. This one is from Jack Dibb. He asked, this part of the US is just beginning to look hard at offshore wind, with a lot of interest and support, but also already a lot of pushback from groups fearing their use of the ocean will be threatened, especially fishers. Does ORE in the UK face similar issues?
Yes, I think that's a very good question, and particularly for fishers, it is an area of, or has been, an area of concern. I think what we've seen in the east coast of the UK is a lot of opportunity actually for fishers to also take part in some of the inspection work for offshore farms, so to sort of change their operation. But also what we've seen is some careful, well, I suppose in some cases we've seen combination of fishing with offshore wind. So we've been able to continue things like potting, and also there has been, it's not implemented yet, but there is a lot of work looking at co-location of fish farms and so on within offshore renewable energy or offshore wind. I think we also saw a lot of this concern in the southwest down here when we were looking at wave energy, or the wave hub. A lot of concern from fishing and also from surfers actually, who are very worried about the wave energy being taken away. And what we found is that, for fishing, as I say, that some types of fishing can be co-located with offshore renewable energy. In other cases, we needed to look at, how to accommodate, payments, if you like, for loss of fishing space, or to make alternative arrangements. But yeah.
Great, thank you. Martin, I think you had some questions you wanted to ask.
Yeah, sure. Hi, Deborah. My name is Martin Wozniak, and thank you very much for this very comprehensive, impressive presentation of all the different things you've gone on with Supergen. Some years ago, we sent grad students to short courses that Supergen organized. This is back when Robin Wallace in Edinburgh was running an earlier iteration of Supergen. Do you still organize these courses, and do you still accept students from outside of the EU? Well, this is actually, you're no longer in the EU, so it's a different question now, but do you still accept students from other countries?
Yes, well, I suppose we haven't been running those courses in quite the same way, that those summer school courses that Robin used to run. I think they, there are quite a few of those run through the CDT. So we have Centres for Doctoral Training for doctoral students, and so those are sort of taken on running the summer schools in a way. But what we do through Supergen is we support the early career researchers. So perhaps we're looking at beyond doctoral students. We're looking at people who are finishing their PhDs or postdoctoral, and we do have training courses planned for those. Not necessarily summer schools in quite the same way, but yeah, specific training courses. I think the thing to do really is to encourage them to join our ECR community.
Does your ECR community overlap with INOR in any way? Is that?
Yeah, well, yes, there is definitely overlap there, and we do work with INOR as well. Yeah, in a way. I mean, yes, it overlaps, but we have some targeted funding for the ECRs, that they can apply for, which is within the UK only. But some of the training and the activities we run, certainly the way we're operating at the moment, everything can be very international. We had about 500 people registering for our assembly earlier in January. So normally we have maybe 100 people, but with being able to do everything online now, then we have a much wider and international audience as well, which is great.
Yeah, great. Well, one more comment. You may not be aware of that yet because it was just recently awarded, but University of New Hampshire will be the lead organization in a Department of Energy sponsored Atlantic Marine Energy Center. Yeah. And we are looking towards spinning up something like Supergen, maybe a smaller version of it, focus on a single coast, not all of it. So we're looking forward to collaborating with Supergen and its researchers on that. We already have some interaction with people due to the IEC standards efforts. So, for example, I'm on a group together with Tim Stallard and some other people from the UK. So there's already quite a bit of linkage there, and hopefully under this new AMEC center, we'll be able to strengthen those quite a bit. But yeah, looking forward to that. So
yeah, that is absolutely fantastic, and we'd be very keen to. I think as I say, a large part of what we're trying to do is to work with international groups and explore ways that we can work together, maybe through and bringing our researchers together, bringing people together. Basically, we've done some work in offshore wind with UMass actually a couple of years ago now, and did a workshop together. But yeah, that would be great. Very keen.
Yeah, we're trying to bring all this together here right now. Right now at the Department of Energy, there's a separate water power office that funds tidal and wave, and then there's a separate wind power office that funds land-based and offshore wind. And then you have other research thrusts that fund aquaculture. So there's sort of, and I hope under what we now call the blue economy, some of these things are going to converge a bit more as they should, as you pointed out. They should, So.
Yeah, well, we had a similar situation with them being dealt with in those different categories, but bringing it together, I think, is makes a lot of sense. It works well.
Great.
Are there any other additional questions? Okay, I see one from Marina Morales. She asks, does Supergen have any programs for high school students to be a part of?
Well, we do quite a bit of outreach. We try to do a bit of outreach, working with schools and all age groups. I mentioned a couple of things where we're developing at the moment. We really would like to try and encourage, as I said, better diversity in engineering and in energy, and I think you need to start that at a very early age. So we're working on an early years picture book, sort of 3 to 5 years. So I'm not sure how that's going to turn out, but we really want to focus in that sort of age group. We're also developing sort of teaching materials for, we have GCSEs and A levels here, but for the national curriculum, we want to develop materials so that school kids learn about this offshore renewable energy in school. And we've just launched this games app. So if you know anyone who likes developing computer games, then please ask them to have a look. There's a prize going for that. But yeah, I suppose the materials that we're trying to develop will be accessible to school students. And I would say that if you're interested in offshore renewable energy and want to find out more about it, then the research landscape, we're hoping that will be a really accessible tool that you could use and find out some good information. It's got sort of different, but I think appropriate information for different levels, and hopefully you would find that a useful resource. So I would suggest if you're a school student, high school student, you're interested in this area, I would say this, but please do explore our website and have a look, see what you think.
Awesome.
I hope you'll find it interesting.
Okay, great. Any other last minute questions? All right, I think that is it. Thank you so much again, Deborah. That was really such a wonderful talk. And we will see you all next week for our next seminar. Thank you, everyone.
Thank you very much. Thank you for inviting me.
Thank you very much.
And I look forward to working together, Martin.
Yeah, I'll keep you updated how this all transpires. We're currently in award negotiation with DOE, so it'll take 2, 3, 4 months to get everything aligned. But we have a pretty broad charge with regards to the Atlantic region to bring all of the research capabilities together to develop a couple of our test sites towards accredited scale testing under ISO IEC. Broaden our industry links. So this and of course conduct marine energy research. So there's sort of a little bit of everything in there. And you may be familiar with the Pacific Center, Pacific Marine Energy Center, Washington, Oregon State. Bryson, Brian Pelagi, Jeremy Casper. So we will be the East Coast version of that in some sense. That is the idea, yeah. And we've been working towards this for a number of years, and our team includes Stony Brook University, Lehigh University, North Carolina Coastal Studies Institute. We have EMAC on the team to work towards accreditation. We just had a conference call with them earlier today. And also the 3 national labs in the U.S. that work on marine energy. So that's NREL, Pacific Northwest, and Sandia. So there's a lot of good things happening here.
Excellent. That sounds great. I look forward to hearing more about that.
Yeah. If you any good students you want to send our way, we'll appreciate.
Well, wouldn't it be great to set up some student exchanges? How about that?
Yeah, or if you have any postdocs, any people who want to take the next step after their PhD, there's currently a lot of opportunity here for that, I think, in all of the areas. So,
fantastic.
Yeah, well, thank you very much for spending some of your Friday evening with us. And
it's been a real pleasure. Thank you very much.
It's a perfect COVID thing to do, right? So.
That's right.
All right, thanks.
All right, thank you very much, everybody. Bye-bye.